In chapter three, the title is called Applying the Supply and Demand Model, but I actually think that's a pretty bad title because essentially all that this chapter is about is elasticity and taxes. And I actually think that elasticity is probably one of the most important concepts in economics. Understanding of elasticity. I mean, not everyone's going to be an economist, so if we start thinking about all the things that what can people do with just economics in general, um, many people go off into the business world, and quite honestly, my value to the private sector as an economist, I was going to care about my research into quasi public goods, really. Most of the time, anyone that would care about my stuff would be, or anyone that would care about the work that I do, I don't know, I'd probably get hired to do elasticity studies. So we're going to talk about that. As you'll notice here, I'm usually skipping slide two because that's just the learning objectives. And let's just get right into slide three. So we already know the basics. The basics being that demand curves are downward sloping and supply curves are upward sloping, such that we generally know, um, right, that for a demand curve, that when the price goes down, the quantity demanded goes up, or vice versa, that when the price goes up, quantity demanded goes down. And that for the supply curve, again, what we know is that when the price goes up, the quantity supplied goes up, and that when the price goes down, the quantity supplied goes down. And that we would generally think of this as an upward sloping supply curve and a downward sloping demand curve. But quite frankly, that's not enough. What we need to talk about is, besides just the shape of the curve, we also want to talk about the sensitivity of the curve. Meaning, um, is the quantity demanded or quantity supplied very sensitive, not sensitive, or equally sensitive to price changes? Um, as an example, right? If you were to tell me, so I use an iPhone, and if we think of all the ways in which Apple has very ingeniously um, uh, figured out how to keep me locked into it, they've done a pretty good job, right? My wife, who uses an iPhone and isn't that tech savvy, I doubt she would ever move away from it. So then the whole prospect of her not being able to locate me, send me a message, where it's got a blue bubble, right? All those kinds of things would make it impossible for me to ever get an Android phone, which then means that the price could be raised quite a bit, and I probably would not change my decision to purchase an iPhone. As opposed to my favorite candy. So my favorite candy, I like Good and Plenty's. It's a black licorice kind of candy. But honestly, candy's 40 something years old. Candy's not an important feature in my life as it was when I was a kid or a teenager. So now, if you raise the price of candy, I probably will just stop buying it. I don't care that much about candy. Um, and so we can imagine there, I'm quite sensitive to price changes. Now, in this slide, what we're talking about here is how is the supply of avocados. Um, it obviously depends on the price of avocados, but how closely does it follow that? See, avocados are going to be, I mean, I do have an avocado tree and I don't harvest it or anything, so I'm not one to really know much about them. But I understand the basics because I've got a tree in my yard. And so the basics would be is once you have that yard, once you have that tree, you're getting avocados. And it's not like if the price of avocados went up, I could dramatically increase my supply because it depends on trees that are slow growing. Then we can think about how people use them. What about the demand side of it? On the demand side of it, we could think that people use it for like what, avocado toast, guacamole. I don't know actually what other people use it for. Right, but sometimes those kind of people, especially for like guacamole, they'd be like, dude, I could never eat chips without guac, and so then they would have to get the avocados to make the guacamole to eat it with the chips. When we talk about that sensitivity, insensitivity, equally sensitivity, the synonym for sensitivity would be elasticity. Now, where are we seeing that? Like, how could we see that? Well, we can kind of see that here. So look at what we see here. Here we see a demand curve where it is somewhat sensitive to price changes. That as the price goes down, in this case, by 20 cents, the quantity goes up by 8. Here, you could have an infinite change in the price, and it causes no change in the quantity. And here, if you were to change even the price by a little bit, you would completely lose all of your quantity. This concept of elasticity is not the same as slope. I'll repeat that again. Elasticity is not the same thing as slope. However, we can eyeball it and see in general, we can make linkages between the slope of a curve and its elasticity in general, but they're not the same things. And you have to have a curve intersecting that curve to be able to talk about some relative elasticities. So what would we call this here? This would be infinitely inelastic. This would be infinitely elastic. Here, the elastic would be a negative number, so elasticity of demand is always negative because it's downward sloping. But here it would just be some number between, it'd be negative, and it'd be between 0 and -1. Right, so it's going to be some negative number, and it's going to be between 0 and -1. Here, it's infinite, negatively infinite. And here, it's equal to 0, as it is infinitely elastic. So elasticity of demand, always negative. And so here's what we see here. Now, as I said, elasticity is not the same thing as slope. And the reason why it's not here is because when we're looking at the elasticity of demand, specifically the price elasticity of demand, we're talking about price changes. And so elasticity in general is all about percentage changes. Now, there's lots of ways to calculate percentage changes, and even as I tell my principles class, this is not a percentage change class. There's lots of good websites out there that will tell you percentage changes, and quite frankly, if you go into Google and I just say right, it will tell me what the percent is, even if I just type it in as as a Google search term, it'll tell me what it is. But there's obviously websites out there where people have made a living off of building a website that would tell me that this is 100% change, right? And it would even walk you through the math. I don't need you to walk me through the math. The whole idea here is that these elasticity are these percentages. It's not always going to be with respect to price, because it could be with respect to other things. Here, when we're looking at price elasticity of demand, we're talking about the percentage change in the quantity demanded over the percentage change in the price. And as I said, for a demand curve, it's always going to be negative, because either the price is going up and the quantity demanded is going down, or the price is going down and the quantity demanded is going up, which gives it a negative term. And again, we can imagine it going all the way out from 0 to negative infinity. And so that's what we kind of start to see here. Again, we are not a percentage change class. Some professors, some classes, they really focus on, can you calculate percentages? I don't doubt that that's an important life skill, but we've got enough things to worry about in this class without having to worry about, can you calculate percentages? Lots of different ways to do it. You can do the midpoint method. You can do new minus old over old. You can go into Google. There's apps. Lots of different ways to calculate percentage changes. But once you've figured out what your percentage change strategy, calculation strategy is going to be, what I care more about is, how do you understand, how would we represent that? So in this case, elasticity of demand, price elasticity of demand, is equal to that percentage change in the quantity demanded over the percentage change in the price, which in this case is a -3 over a +1, which is equal to -3. Is that a reasonable number? Well, the only way we could tell if it's reasonable is that we needed it to be negative. But other than that, right, we just have an indication here that it's neither infinitely inelastic nor is it infinitely elastic. It's just a normally shaped demand curve with some visible slope. Now, let's start to work through this. Like, what kind of information can we get from the general function? So we have a general functional form of a demand curve where it is Q equals some constant term minus, because it's a demand curve with a slope term and then the price variable. So that's why we've got our constant term here, and we've got our slope term here. Now, the slope term would be how we're changing our Q over P, right? So if we just draw out our demand curve here, right, slope is equal to rise over run. Right? And if we think of that as the negative of that slope, be our delta Q over our delta P, which, if we go back to here, right, our elasticity function itself is equal to delta Q, delta P, P over Q. Putting it back over to here, what we can see is that if we want to write out the elasticity of demand, that would be our percentage change, delta Q, delta P, P over Q. But in essence, what we can do is replace that delta Q, delta P right here with my slope term. So hence the elasticity the price elasticity of demand is my slope term, my negative b, and it's going to be my relevant p over q, whatever point I'm at. So let's actually put this into practice here. So here I've got a demand function. Q equaling some constant factor minus the slope term P. And I'm asking, what is the price elasticity of demand where the price is $7.20 per bushel? Okay, so what I need to do first is I'm going to need to find out what the Q is. So 15.6 minus 0.5 times 720. It's not that I don't know how to calculate things in my head. I'm just trying to. I don't have any students correcting me here as I'm writing things out, so I have to be a little bit more careful. I want to make sure I'm not screwing anything up. So Q equals 12 and P equals 720. So for my equation for price elasticity demand, where it's equal to negative BP over Q, that would equal negative 0.5, 720 over 12. And I'm getting negative 0.3, which would indicate that this is slightly inelastic. How do I know it's slightly inelastic? Because it's between 0 and 1 in absolute value terms, or between negative 1 and 0. That would mean that it's relatively inelastic or insensitive to price changes. Let's go on the next slide here and I'll start to write this all out. As you saw here, they, as I indicated in the previous slide, they put in that $7.20 price into the demand function, solved for the Q. Then they put it into the equation for our elasticity of negative BP over Q. So that would be negative 0.5, the 0.5 coming from the B term here, from the demand function, times 720 over 12, equaling negative 0.3. And what we see here, and just to kind of further highlight that elasticity is not the same thing as slope, is that even along a straight demand curve where the slope is constant, the elasticity changes along the curve. Now, let's look at the next slide here, because you might be like, well, how could that be? Well, what we what we see along a demand curve, and this would have a constant slope, right? We can see this, and we can see that the line is constant. That's changing by what? By about 7 for 3.9. So it looks like about 2, about negative 2 or so, a little bit, pretty close to that. But remember, elasticity is a percent. Now, what does that mean for us here? What that means is that the base number that we're at matters a great deal. So if elasticity is the percentage change in the quantity demanded over the percentage change in the price, well, at this point here, close to this right here, you've got a very low quantity but a very high price. So if we did a 1 unit change, let's just say that this number here was 1. And let's just say that this number was 100, just to make my math a little simpler here. A 1 unit change would be a 1% change in the price, but it would be 100% change in the quantity, right? Because it'd be going from like 1 to 2 versus going from 100 to 101 in terms of price. Which would mean that in elasticity terms, I'd have 100% change in the quantity demanded over 1% change in the price, which would be a really big number, right? Where we've got it being incredibly elastic. And then the opposite would be true here, right? Way down here, again, let's say that that's now 1 and this is now 100. For a 1 unit change here, I'd now have a 1% change in the quantity, and now I would have a 100% change in the price. Right, and now 1, but it'd have a 0.01, right, as opposed to 100% change. So, and that would result in something being, as opposed to being pretty elastic, this would be something that's pretty inelastic. And again, you can imagine getting to a point where things would be perfectly elastic or infinitely elastic. And this would be a situation where if the demand curve is horizontal, which it would be when we start to talk about things, perfectly competitive firms, would be that people would buy as much as possible as long as the price is less than or equal to the market price, the equilibrium price. But even if it changes just a little bit above the price, no one has any allegiance to any particular demand, particular brand, and the demand falls to 0. How do we see that in reality? Well, the way we would see that in reality would be, now I'm just a normal consumer. I'm not particularly environmentally conscious, nor am I particularly health conscious, which means I don't care whether my apples contain chemicals or are organic. I'm pretty much a price kind of guy. So, I have no allegiance to a particular brand of apples, a particular kind of apple, nor do I care how it was grown. I would say that my demand for apples is pretty darn close to perfectly elastic. I'll buy whatever is cheap, and I don't care the type of apple or how it's grown. Farmers then would have to do their best to create some inelasticity because that's how they're going to make money, right? You're not going to make any money selling a perfectly elastic good because then all you can ever do is charge the market price. It's going to be very difficult to get any price advantage. So what you have to start doing is say, I'm growing my apples organically, and that means that you're eating less chemicals, or my apples are more tart, or my apples don't have as many bugs, or whatever. Right now, we're starting to talk about why things like marketing exist. Right, it exists because you want to describe your good as having some inelasticity, which now gives you some pricing power if you're a firm. And on the other side, you've got firms that are sometimes selling perfectly inelastic goods. This is a pretty darn good industry to be in, right? Because now you are selling something essentially that is essential. Hawaiian Electric, right? HECO is selling a product that is quite, maybe not as perfectly inelastic as it would be on the mainland, because we've got lots of sun and it's pretty cheap to generate electricity here because we have so much sun. But still, electric is generally a perfectly inelastic good. Many pharmaceutical drugs are inelastic goods. And so we can imagine that these goods then have lots of pricing power, and the way that they look is different. The way that they look is that they're generally a little bit steeper, generally speaking. And so that's what we see here. We've got our perfectly elastic demand curve, which is generally horizontal. We've got our perfectly inelastic good, which is vertical. And then essentially, right, we can understand some consumers, right? Like for myself, I don't take insulin. I'm blessed that I don't need insulin for any reason, right? So in my case, right, I'm not going to buy any, but we would imagine, right, that a person who does need it would be at a point, right, where it's at a certain price and they consume that amount that they need. But they're not going to overconsume insulin, despite whatever the price is, right? At some point, you're not going to buy more than you need, just like you're not going to buy more electric than you need. It's a pretty established amount that people are going to buy. So as I said, what is the skill that I have that firms would want? Well, they're going to want me as a person that knows a great deal about elasticity. As I even said with my dissertation research on academics publishing their research, generally speaking, if you're a researcher in a field, you have a few journals that you rely on that you're willing to publish your research in. And as a reader, you're generally looking at only a small number of journal titles. And what that does is it creates a situation where you have certain journal titles having quite inelastic demand for publication in these things. And so what you would want to see is you'd want to see a different price being charged to publish in that journal as opposed to another. Now, when firms are considering price changes, they need to consider what the elasticity of the product they're selling is. If the product they're selling has elastic demand, if the thing that they're selling has elastic demand, that would mean that the changing the price leads to a larger change in the quantity demanded as a unit, right? Because we're saying it's much more sensitive. Well, where revenue is equal to P times Q, this is essentially going up by a little bit, and this is going down by a lot, which when you multiply it would generally mean it would be going down. So that's why here we're saying a higher price actually reduces revenue. So you can now see if you're selling a product that has that is elastic, you don't have a lot of pricing power. Again, as a firm, your goal is going to be to try to create instances where your product has some inelasticity, which you have to do with things like marketing, patents, You need to find ways to distinguish your product from others. And when you do that, here what we're saying is that if I change the price, it causes a very small change in the quantity. Which again, if we're looking at revenue then, which is equal to P times Q, this is going up, and this is only going down by a little bit, which means that in general, my revenue is going to be going up. This is your advantage to selling something, to investing all that money in marketing, in patents, etc. Right? Why is a Tesla car as an EV car any different than an electric Ford? Well, right? I mean, we generally speaking think of Tesla like either. I drive a regular old junky car. But right when we think about, for many consumers, Tesla is the electric car, the only electric car that they would buy. Or why, here on the islands, for instance, if we think of schools like, for kids like Punahou or Iolani or Kamehameha or Midpac, right? Those are like the big schools that perhaps have a bit more inelastic demand than, as soon as I say a school, I'm going to piss someone off. Elastic demand schools like, like Mary Knoll, right? A Catholic school, as opposed to, Hawaii Baptist or Island Pacific Academy over on the west side. Right. I mean, all these, I'm not saying that these consumers are a bit more elastic, but, right, there's a bit more competition at their level. And so we can start to see that graphically here, that if I'm looking at revenue again, which mathematically speaking is going to be equal to price times quantity, that I'm changing from a situation where at P1, my revenue is equal to A plus B. At price P2, my revenue is equal to areas A plus C. My revenue has fallen, right? C is a pretty small area compared to B. So this good, we could already tell, is pretty elastic. As opposed to inelastic, especially in this case, if it's perfectly inelastic, you can change the price and there's no change in the quantity. So, right, what is this the story of? That's the story of pharma for you, pharmaceutical drugs, right? I'm not pushing for one president or the other. I don't care about that kind of stuff, honestly. They all suck. Right, but one thing that Biden did do was he put price caps on insulin, which would be, and for right, if you suffer from a disease that requires you to take insulin shots, you would be perfectly inelastic for insulin. And so drug companies were then charging a lot of money so they could make a lot of money. With a price cap, now they can't make as much money. Okay. So the question then becomes is, does a price increase cause revenue to rise or fall if the demand is elastic? How does this revenue change if the demand curve is inelastic? Well, what we're seeing here is that if it's elastic, now we know that revenue falls if the price is going up. And over here, if it is inelastic, then revenue increases if the price is increasing. And I guess you could just say that here. Or say that here. And looks like they did something for Amazon Prime in the book. Honestly, I'm not reading the chapters here. I mean, I know the material. I mean, I read it, I'm sure, a decade ago or something like that. I'm not dismissing that. But really, more of what I'm talking about here, um, what we're seeing here is that once Amazon locks people into Prime, they have a better ability then to charge consumers more by making consumers have their go-to online store be Amazon, right? And it gives them some degree of inelasticity and an ability to charge consumers higher prices. Now, one thing we know as well is that elasticities change over time. These elasticities, as they change over time, what we can see is that as you have a longer time period, consumers can figure out different ways to substitute towards other goods, um, or there's going to be a difference, like in terms of how long you can store the good, right? Like in terms of fruits, right? Um, for particular fruits, you might not have a lot of substitution abilities, nor can you store the good for very long. On the other hand, if we are talking about, I don't know, like, uh, geez, I'm just trying to think of a food here, like an MRE, right? Like a meal that's ready to eat, like, like they use for emergencies or in the military or things like that. In those kinds of goods, you can store the good for an incredibly long period of time. And so you can imagine you could buy it when it's really cheap and then store it for 2 years or 5 years or 10 years, and then use it when you need to. Um, or other goods you can't substitute in the short run, but as you have a longer time frame and you can change your actions, you could imagine that you could become more elastic. So generally speaking, the longer the time period, the more elastic, um, the more elastic demand comes. Um, as goods are easier to store, um, what we um, what we see in general is that if goods become easier to store, um, the demand will be it'll become even a bit more uh, inelastic because right now I can store things for a much longer period of time with respect to um, uh, I'm not going to be as sensitive to price changes anymore because I can just store it over a longer period of time. Okay, I'm going to pause right here. Okay, so one of the other things that we can notice here, instead of calculating price elasticity of demands, we can calculate income elasticity. So notice here, and don't get freaked out by it, but Perloff, the author of the textbook, changes the term. So when you see E that looks like this, that's price elasticity of demand. I don't know my letters that well in different. I don't know if that's like what the hell that is. Um, whatever. I don't even. Whatever. He's referring to this as income elasticity. When it comes to like your problem sets or your exam, which won't be, which will be handwritten, it won't be something we do over the homework system. As long as I know what you're talking about, I'm okay. So here, when we're talking about income elasticity, now what we're saying is what is the percentage change in the quantity demanded over the percentage change in income, where Y stands for income. So much as the same way we discussed things when we talked about price elasticity of demand, um, now instead of delta Q over delta P, P over Q, now we have delta Q, delta Y, Y over Q. And so now we're saying that we've got a percentage change in quantity demanded over percentage change in income. That for a 1% change in the income, we have a 3% change in the quantity demanded. Now here, it's not the number itself that matters, although it does, but rather it's the sign of the number that matters. So remember, for price elasticity of demand, it was always negative. But for income elasticity of demand, the fact that this is positive means that it's what we would call a normal good. When income goes up, people buy more. And when income goes down, people buy less. Not too unusual. If it's negative, then this would be what we call an inferior good. And inferior goods would be ones where we could think of it like store brand of a food item. Or for some people, having an Android phone is an inferior good. And when you get richer, you buy an iPhone, right? Or used cars being inferior. Inferior because what you can imagine that consumers do is as soon as they get a better paying job, they buy a new car. Back to avocados. Oh, geez. And you know what that means? By me telling you I don't eat avocados, I was giving you an indication of how poor I am, generally speaking. Darn it. Okay. So now we're being asked to calculate what the income elasticity of demand is at Q equals 40, Y equals 4,000. Well, what we would need to do here, right, is do our substitutions. Let's just jump over to, where are they solving that? Are they solving that? Yeah, here they go. They start solving it here. Oh wait, no, they didn't. Oh, okay, so let's solve it here then. Okay. So we could imagine here that we've got our constant term. Um, Okay, and then for our elasticity, income elasticity, now again I have my delta Q, delta Y, Y over Q. Where do I get that from? That's from right here. So what we would have to do here, right, is we probably need a little bit more. I'm not sure why they're making it a problem like this that you need to solve, because we actually would need a little bit more information for this point in time information. We need a little more information here to solve this. Beyond income elasticity, we also have cross-price elasticity, which again would also be important if you were a company. You'd want to know this information. You'd want to know what your competitors are. Your competitors selling substitute goods? Are they complement goods? How strong of a substitute good are they to yours, right? Is Apple iPhone really worried about Google's Android system? I don't know, right? I mean, you'd have to, I'm sure they've got, actually, Amazon is actually the largest employer of economists in the United States. They have the most economists. So I'm sure Amazon has done enough, they have enough people out there figuring things out in terms of how to price their goods and what the goods are worth. I'm sure Apple has hired just as many fewer, but they've hired a great deal of economists to try to figure out how their good stands. Now, what we're saying, though, is that for cross-price elasticity, it's delta Q, change in the quantity of the product I'm selling over the change in the price of the other good. Now, the sign here is going to tell me whether my good is a substitute or a complement. If I'm selling a substitute good, what we're going to see here is that for the substitute good, if the substitute good is falling in price, then we would know that the quantity demanded of the substitute good is rising. And that if my quantity of my other product is also rising, then what we would see here is that if it is negative, if my cross-price elasticity is negative, what that's implying is that both my one product is going up in quantity as well as the other. That would imply that they are complementary goods. They are goods used in conjunction with one another. As for a substitute, what we'd be seeing is a positive sign. Now, how would I see that? So I would have my, if I still had my other good falling in price, leading to my other product going up in price, which we know from the law of demand. But now my other product is going down, right? Because if I have a down and a down, that would be a positive sign. But this other product, I'm buying less of it while the other one is going up. That would mean that one is replacing the other. So when I see a positive sign for my cross-price elasticity of demand, I have an indication that they are substitute goods. So in the product here, the fact that it's negative means that I have complementary goods. Or you could just read this much fancier way in which things were written. But if you were just to look at that slide, it's not entirely obvious. If I didn't explain it, you'd be like, well, how the hell did he know that? We'll go here. Right here, I'm just describing the law of demand for the other good. And then I'm telling a story. What would they have to be for this to be going up and this to be going up as well? That would be that they are complementary goods. And it's negative because you've got one going up and one going down. Here again, for the substitutes, I've got them both going down, so that's a positive. But as they're both going down, you can see one is going down in quantity and the other product is going up in quantity. That would mean that they are replacing each other. Okay. Let's go back to our avocados. Okay, so now we would have the situation where you could solve the cross-price elasticity. If we had a little bit more information, we could solve for that. We could solve for that with by substituting in our quantity of 80, our P subscript T of 80 cents, and we could solve for this alternatively with a little bit more information. And so we've got price elasticity of demand, income elasticity, cross price elasticity, and now we have elasticity of supply, which the author Perloff is denoting with N. So now the Q here is no longer quantity demanded, now it is quantity supplied. So go back to delta Q, delta P, P over Q, but again, the Qs are now quantity supplied. By its very nature, elasticity of supply is always positive. It's always positive because of the nature of the supply curve being upward sloping. Right? It's either price is going up, quantities supplied is going up, or its price is going down, quantities supplied is going down. And so here, what we're seeing is that we could also, along a supply curve, we could talk about the elasticity of supply. Whereas we did for elasticity of demand, price elasticity of demand, just to remind ourselves here, the price elasticity of demand right, it was negative B P over Q. Now for elasticity of supply, it's H P over Q, where H is my slope term, G is my constant term, and the slope term is delta Q, delta P. Change in quantity, change in price. Now, what are we going to do with that? Well, we can now solve, if I give you a linear supply function for corn, we can now solve the elasticity given a price and given a quantity. So let's do that. And again, as I do things here on my calculator, if you see mathematical errors, let me know. I don't have, what I like about teaching in person is I make math errors all the time, dumb math errors all the time. And what would be nice is if I had someone telling me, right, you're making a mistake here or there. That would be kind of nice here. So again, we can prove here that at the price of 1.8 plus 10.2 is in fact 12. So 12 equals 12. So that's all good there. But now what we need to do here is our delta Q, delta P, P over Q. So my B term here, or sorry, not my B term, my H term here is 0.25. My price and my quantity. Which gives me positive 0.15. Okay, so now what did I do here, right? So here I did this just to prove, yeah, I know they gave us the answer here and they gave us that price and quantity, but I did the work here just because I wanted to prove to myself that I didn't have any errors. 12 should equal 12, so I knew that my price and quantity were relevant. So now what we're trying to do here is find the elasticity, the point elasticity of supply at price 7, 20, and 12. Because remember what's going on here. You've got an upward sloping supply curve. And all we're saying here is that at the price of 720 and at the quantity of 12, what is the elasticity at that particular point? We then put it into that equation and we find that at that particular point that the elasticity is 0.15. which gives further evidence of the fact that the elasticity changes along the curve, because we can imagine that the elasticity is going to be different here, which you would see right here, right? And they solved it basically. And right, you could on your own, I'm not going to do it here, but on your own, you could put in those different quantities and prices and find those different elasticities. Now let's do one of them for you. I don't know why they're saying it's 11. Or sorry, I don't know why they're saying it's 0.125. I got 0.1206. That's odd. Why would we be off so much? Well, let's just try this one here. Point 0.1355. Yeah, which would round to 0.136. But why are they saying it's 0.125? It's not. Did I put something in wrong? Just make sure. Sorry if I'm wasting your time here. You can just fast forward this if you want to. But I see a 0.1206. Well, someone's wrong somewhere. It's not 0.125. I'm getting 0.1206. Whatever, it doesn't matter. If you set it up this way on a problem set, or if you set it up this way on the exam, I'll know what you're doing. You're not going to get it wrong. I'm hesitant to say that the author is wrong, but I think there's a reasonable chance it could be possible. Same thing as price elasticity demand. We can imagine that it changes over time, and that it's generally going to depend on, again, the time frame that we're talking about and your ability to store the good over time. And, ANWR, that's right. That was the, ANWR was the wildlife reserve that had oil in it. And obviously, the oil, when it's stored underground, it is obviously stored pretty well. And here, what we're talking about here is we're given our supply elasticity, our elasticity demand, our supply elasticity, the price, and the quantity. And then it's asking, what would be the effect? What kind of change would we see? Let's thinking, have us, Well, essentially what we would do here is we could look at then the price of it changing, in this case, by 85 cents, right? And we see that the price is going from $50 a barrel here, and that it's going from sorry, I keep going back to this because that it's going from its pre-ANWR, pre-drilling point from 94 and 50. So 50 and 94. So there's our original equilibrium E subscript 1. And it's asking us to now calculate given this, what is our new supply function? Well, we can calculate that. And the way that we can calculate that is we know now what our supply elasticity is. So in other words, right, that's our delta P, delta Q, P over Q. How did I know that? Well, going back to right here, delta Q, delta P, P over Q. Sorry, I think I wrote it down wrong here. Yeah, sorry. Didn't mean to. Delta Q, delta P, P over Q. Now what we can do is we can start to put in our variables here to find our shift. If we know that our annual production is going to be 0.8 million barrels per day, that would be our delta Q. And we know our P over Q. So all that we'd be really doing here is finding out the delta P. In this case, we would have right, and then we can let's see here. 0.8 times 94 is 75.2. And to give you an idea of graphically what we've now solved for, right, is now we've said at that price we've actually found this price, right? Sorry. This price right here. Oh, I can't. Sorry, I'm trying to draw it straight here. Okay, so let's go back here. Now, by cross multiplying, we can actually solve for the new equilibrium. Our new equilibrium being one where our new function, our new supply function, we now have to find that by setting it equal to the original demand curve, which was unaffected, which we can find the original demand curve using this price elasticity of demand. You'll see this in the homework, and we'll wait to get the actual problem here to solve this out a bit more. Okay, so elasticity, that was the bulk of what we were doing here for this chapter. And now we kind of finish up this chapter by talking about taxes and the effect that taxes have on the supply and demand curve. I'm going to pause right here for a moment. Okay, so for taxes, we have two kinds of taxes. We have, in general, we have specific taxes and ad valorem taxes. Specific taxes are sometimes called quantity taxes. Ad valorem taxes tend to be a percentage of the purchase price. So our question would then be, is that as we impose taxes, what effect does this have on equilibrium prices? It actually depends on the elasticity. In general, drinking soda is a bad thing. I don't think I'm surprising anyone by saying that. But if most consumers, myself included, I like soda, but I'm not inelastic. I'm not going to live or die by having my morning Coca-Cola. Right? The whole idea would be is that if the price went up because a tax was imposed, that's going to be a great way to stop me from drinking soda and having all these unhealthy consequences. Or the other way would be smoking, right? It's inelastic for consumers who are addicted to tobacco. Yet, if you raise the price enough, you could imagine getting to a point where people stop smoking finally because you've raised the price far enough. Now, when we talk about who pays the taxes, sometimes we think of these, we confuse things by talking about things in terms of who has to legally give the tax money to the government that's collecting the tax, which would be what we call the legal incidence of the tax. That's not really that important. It really doesn't matter. What matters more is the economic incidence of the tax, meaning that when a tax is imposed, sometimes the seller, even if the seller is legally responsible for remitting the entire tax amount to the government, to some extent they might bear part of the tax burden by not raising the price by the entire amount. And they'll basically allow the tax to kind of cut into their profit margins a little bit. All that is going to depend on how elastic or inelastic the good is. Okay, so let's start with this. Right, here's our descriptions again, which I already have stated, but an ad valorem tax is a percentage tax, a unit tax is a specific tax, and it doesn't really matter which kind is used. Graphically, they'll look a little bit different. So here is our specific tax. It would just raise it by a parallel shift upwards because it's per unit. The tax is going up. Now the yellow box here is measuring how much is legally being remitted to the government, that amount, from 560 to 820. So this must be a $2.40 unit tax. But what you can see here is that the consumer isn't paying the entire $2.40. The consumer used to, before the tax was imposed, paid $7.20 and the supplier got $7.20. Now, there's a $2.40 tax. And how do I know it's that? Because that's 8 minus 560, which is equal to 240. But now, after the tax, the consumer is now paying $8. That means consumers are paying 80 cents more. And producers who used to get $7.20 are now getting $5.60, which in this case is $1.40 less. So consumers are paying 80 cents more. Producers are ultimately receiving $1.40 less. So look at that. Right? Even though the government's getting the whole $2.40, it's not that all that tax was passed on to consumers. Only a portion of it was. And producers also paid a portion of it. Now, why that difference between the two? Well, this must indicate that to some extent this good has got some elasticity, and the firm had to take on a bit more of the tax so that they don't lose all their customers. They're going to lose some because the price is going to go up by 80 cents, but they're not. If it had gone up by the whole 240, they would have lost a lot more consumers. Now, again, it doesn't matter who legally has to pay. Sorry, I didn't mean to shift it there. It doesn't matter who has to pay the tax to the government. It just determines whether you are shifting the demand curve or the supply curve. Here, the supplier was legally responsible for remitting the tax to the government. Here, the consumer is legally responsible for remitting the tax. But it doesn't matter. You still get the same result, an 80 cents paid for by the consumer and $1.40 paid for by the producer. So legal incidence doesn't matter. It doesn't matter who is ultimately paying the government. What matters more is the economic incidence, meaning how this is being split up between consumers and producers. Okay, so I'm assuming, show mathematically the effects of the tax of 240. Okay, well, didn't we kind of do that already? Let's just see where we're going with this. Okay, so let's go to, okay, so yeah, here we go. Let's just get into the problem here. Okay, so as the title implies here, which I absolutely agree with here, the tax effects do depend on the elasticity, or as I would even rephrase it further, I would say that the economic incidence of the tax depends on the elasticity. Okay, how much does the price change equal for the supply elasticities and the price elasticity of demand? We've got a price elasticity of demand here. We've got a supply elasticity of demand here. We've got a change in taxes here. It's not hard to solve this, gang. All we got to do is start substituting things in, right? There's our demand, price elasticity of demand. There's our supply elasticity. And there's our tax. Which allows us to find now how much consumers are paying more, 80 cents. So that's our equation for how much consumers are paying more. And right, we could just do some simple division here to find out what percentage of the tax. And in this case, consumers are paying about a third of the tax. And then if we have a perfectly elastic supply curve and the demand curve is just regular downward sloping, how would a $1 specific tax, meaning unit tax, affect consumers and producers? Well, what we can see here is, again, we would shift the supply function because this is legally being imposed on the sellers. So it would raise the price by $1. But because it is perfectly elastic, what we see here is that consumers in terms of what they're paying, they're going to be paying the they're going to be paying the well, not practically. They're not going to be paying any portion of the tax, largely because these firms are competing for the product, for the consumers for this product. And so even if the price were to go up infinitesimally small, they would lose all of their demand. So the producer has to cover all of the amount. Now, how do things change graphically when we change this to a ad valorem tax? Well, instead of it being a parallel shift, it starts to pivot, right? And in this case, it's changing by, let's say, 5% or 10% or whatever. And that's how we would see things changing here. Rather than being a parallel shift, as it is with this blue line here, if it's a ad valorem tax, also, again, shouldn't matter too much. Really shouldn't matter at all which one you use, ad valorem or specific. You could structure them, you'd have to pick the percentage in a way that you could still capture the same amount of revenue. Okay, again, for these solved problems here, as I'm looking at them here, I'm gonna address many of these when I talk about the homework. So I'm not trying to skip them here in the lectures. Rather, I'm just using them as points of reference that I'll talk about in a little bit. So here we see we've got if we were just describe this picture in general, we have an infinitely inelastic supply function and a ad valorem tax imposed on the consumer. And again, we can see now with this infinitely inelastic supply curve that the consumer pays all of the tax. And one of the other things we know then in terms of the gasoline tax, in terms of who pays it, we can see that it matters whether we're talking about the short run and the long run. Because in the long run, the supplier can change their supply, right? They can just leave the oil in the ground. But in the short run, they're going to have to get rid of it. And it can change it where the supply is elastic, as it is in the long run, to making the supply completely inelastic in the short run here, which is going to change how who pays the tax. As it becomes more inelastic, then what we would see is that the portion in terms of the distribution of the tax between producers and consumers would change as well.